The Great Red Spot on Jupiter is truly one of a kind. A storm so massive it could swallow Earth whole. Its winds faster than anything we've ever experienced on our planet. For years, scientists have looked at its sheer size and power. But recent observations have revealed something surprising. The storm isn't as permanent as we once believed. In fact, it's slowly shrinking. And the reasons behind this change tell us more about Jupiter's turbulent atmosphere than almost any other feature of the planet.
So what's really happening to the Great Red Spot? And how does a storm that's lasted for hundreds of years start to fade? To understand this, we need to look at the forces that have kept it alive for centuries. Jupiter's atmosphere is a chaotic world of extreme winds, pressure layers, and swirling clouds. The storm is a massive system fed by smaller storms around it. Over time, these neighboring storms interact with the red spot, slowly siphoning away some of its energy. The storm's edges become ragged, its size diminishes, and subtle changes in Jupiter's atmospheric heat flow can accelerate this process. What we're witnessing is the natural life cycle of one of the most extreme storms in the solar system, a phenomenon that shows even the largest, most powerful weather systems aren't eternal.
But what has allowed the Great Red Spot to survive for centuries in the first place? Unlike storms on Earth, which form and dissipate quickly, this storm is fed by Jupiter's enormous energy and complex atmospheric layers. The planet's rapid rotation creates intense jet streams that surround the storm, acting like invisible walls that contain its energy. Meanwhile, the storm itself generates turbulence that pulls in nearby storms, feeding and sustaining its massive vortex. Yet even this incredible stability has its limits. Over decades of observation, astronomers have noticed that the red spot is gradually losing some of that energy. Tiny changes in Jupiter's internal heat, interactions with neighboring storms, and subtle shifts in atmospheric pressure slowly chip away at its might.
In recent years, high-resolution images from telescopes and spacecraft like Juno have confirmed what astronomers long suspected. The Great Red Spot is shrinking faster than ever before. At one point, being large enough to swallow 3 Earths side by side. It now barely spans the width of 1.5, meaning it has basically shrunk to half the size as before. Its shape has become more circular, while its color has deepened into a darker red. It's a sign that its upper clouds may be thinning, or revealing deeper layers beneath.
Some researchers believe this transformation could be part of a natural cycle,
a period of contraction before the storm stabilizes again. Others suggest it could be the beginning of its slow end, as the smaller storms that once fed it no longer have enough energy to keep it alive.
Now, you might be wondering, is this shrinking storm dangerous? Could it somehow affect the planet, or even us here on Earth? Well, don't worry. Jupiter is 483 million miles away, and the Great Red Spot, even at its reduced size, is entirely contained within its own chaotic atmosphere. The storm's shrinkage won't trigger earthquakes, tsunamis, or any cosmic disasters for us. Instead, it gives scientists a front-row seat to watch how giant storms evolve, interact, and eventually fade. By studying these changes, we learn more than just the fate of one storm. We gain insight into planetary atmospheres, fluid dynamics, and the extreme physics that govern worlds far beyond our own.
The way we study the storm is just as fascinating as the storm itself. Since we can't exactly send weather balloons into Jupiter's atmosphere, scientists rely on powerful spacecraft and telescopes to do the job. Juno, as mentioned earlier, has been orbiting Jupiter since 2016, giving us an entirely new view of the planet's turbulent atmosphere. Each time it passes close, it measures things like wind speed, temperature, and magnetic fields, helping scientists map the storm in 3 dimensions. What it has revealed after all these years is extraordinary. The Great Red Spot extends hundreds of miles deep into Jupiter's atmosphere, far deeper than any storm on Earth. Using microwave instruments, researchers have detected layers of motion that twist and churn beneath what we can see, proving that the storm's true power lies far below the cloud tops.
At the same time, telescopes here on Earth, and even the Hubble Space Telescope, keep a constant watch. By tracking its shape, color, and brightness, they've discovered subtle shifts over the years, from deep red to orange, and sometimes even pale beige. These changes may come from sunlight interacting with the planet's chemicals, creating new compounds in real time. Together, all this data reveals that if the storm truly is shrinking, it could fade away completely within just a few decades, maybe 50 to 100 years if current trends continue. That might sound like a long time, but in planetary terms, it's the blink of an eye. When that moment comes, future astronomers may look through their telescopes and see a Jupiter without its most famous feature. The Great Red Spot will become part of history, remembered through images and data, a reminder of how even the most powerful forces in nature eventually change and disappear.
If you like this video, then subscribe to get short explanations on changes, discoveries, or just how our solar system works in general.